Rewrite the quadratic function in standard form. The function is x squared minus 10x plus 29. Now let's go back to the definition. The general form is in the form of ax squared plus bx plus c. And we want to write it in standard form, which is a times x minus h squared plus k. And keep in mind that the vertex are the following formulas. Okay, so let's go ahead and do the first one by completing the square. Okay, and so by doing so, we're going to first write out what our function states, which is f of x, which is equal to x squared minus 10x plus 29. Okay, now in the second step, what we're going to do is we're going to go ahead and factor out a 1 on the right side of the function. And in addition to that, we're going to factor out a 1. And we have x squared minus 10x. And then we're going to add an n and then subtract an n. And then plus 29. Okay, and then what we're going to do is we're going to write that 1 and multiply it by the first 3 terms, which is x squared minus 10x plus 9. And then that means we're going to multiply the 1 by the minus n, so on the outside of the parentheses it becomes minus 1n plus 29. Okay, now what we need to do is we need to complete the square. So by completing the square, we're going to take the value of n, which is going to equal 1/2 of b and then square it. Well, we know that the value of b is negative 10. So this is 1/2 times negative 10. And half of negative 10 is negative 5. And if we square negative 5, we get 25. So therefore, this is going to represent n, and that's going to represent n. Okay. So now we're going to go ahead and rewrite this as 1 times x squared minus 10x. Now that's plus 25. And then minus 1 times 25, which is going to be 25. And then plus 29. Okay, so now we can then factor this and rewrite this in terms of factoring the perfect square trinomial. Well, what did we have to square to get 25? If we look over here, we had to square negative 5. So therefore, it's going to be 1 times x minus 5 squared plus, well, minus 25 plus 29 is 4. So therefore, we can see what the result is up there. And then if we wanted to figure out what the vertex is, well, again, if you come up here, the vertex is minus h, so it's be h and then k. So then our vertex would then be 5 and then 4. Okay, so that is completing the square. Okay, now the thing we can do is by using the given information above here. So we can use this formula for the vertex using the general form. So in using the general form, okay, we need to identify what is A, what is B, and what is C in our problem. Well, we know that A is 1, we know that B is negative 10, and we know that C is 29. Okay, and so what we want to do is we want to figure out what is the value for H and K. In order to do that, we can just use what we know from our formula. So H is equal to the value of X. Well, what does that represent? Well, that value of X here is this X, which represent this H. So we have X which is equal to negative b over 2a, and that's equal to negative, this is negative 10 over 2 times 1, which is equal to a positive 10 over 2, which is equal to 5. Okay, and then we know that k is going to represent y, and y is f of whatever we get for negative b over 2a. And let's just verify this up here. We can see that k is going to equal y, and the y coordinate is f of negative b over 2a. So we know what that is from the previous result. Okay, so what is the value that we got from the first part? We got 5, so therefore this becomes f of 5. So where do we get the 5 from again? Well, we know that that represented 5 here, so that's what negative b over 2a was equal to. And now when we plug that in, we plug that into the function itself, and that function is 5 squared minus 10 times 5 plus 29. And so here we have what? 25 minus 50 plus 29. And so therefore that gives us positive 4. So now we know what h is, and now we know what k is. Then all we need to do then is just use our standard form. So now recall what the standard form looks like, and that is a times x minus h squared plus k. Okay, so what do we know? We know that from above, we know that a is equal to 1. We know that h is equal to 5, and we know that k is equal to 4. So now let's go ahead and plug that in. So we have 1 times x minus 5 squared plus 4. And then the vertex, again, which we've already found at the beginning, is equal to 5 and then 4.